welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11. That is your class 19. We had done your 18th class of the session in the last classes. And this is your unit 3rd. Unit 1 is your physical world, which we had completed. Unit 2 is your units and measurement, which we had completed. This is your unit 3rd, which is your motion in a straight line, that we have to cover up. And even though we had started this in the last two classes. So now lastly what we had done is all about average velocity, velocity or retardations, and many more applications related to it, length, path length, and the specification, and in terms of positive velocity, negative velocity, rest when an object is in the rest motion, or the car description that we had discussed. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So we'll start discussing about it, and the first topic that today we'll discuss about average speed. So in terms of average speed that we have to discuss here, average speed is defined as the total path length traveled divided by the total time interval during which the motion has taken place, which is average speed is equals to total path length upon total time interval. So in the same way we talk about it for the average speed, and then we'll write it on the formula for the same here. So average speed is defined as the total path length traveled divided by the total time interval during which the motion has taken place. So average speed that we'll be writing here equals to total path length upon total time interval here. So accordingly that we'll discuss about it. So as you can see here, with the same total time path interval and total upon total time interval here, that is being known as for the average speed. In the same way, average speed has an obviously the same unit, that is meter second inverse, and that of velocity, but it does not tell us in what direction an object is moving. Thus it is always a positive, in contrast to the average velocity, which can be positive or negative. If the motions of an object is along a straight line and in the same direction, the magnitude of the displacement is equals to the total path length. In that case, the magnitude of the average velocity is equals to the average speed. This is not always in the case, as you will be see in the following questions will do. And so let's start discussing the question first, so that it will be clear to you how you will find out the average velocity, average speed, average velocity, and average speed in the same different conditions here. So the question first of this unit, that is motion in a straight line, we will be discussing here. The question states that a car is moving along a straight line in, say, OP, in what we had even though discussed about in the last figures. It moves from 0 to P in 18 seconds and return from P to K in 6 seconds. What are the average velocities and the average speed of the car in going? The first part will be from O to P and from O to P and back to Q here. This was the situation has been given, so we'll go for this, and first we'll write it down the question and then we'll solve the same. So the question one we will go. So a car is moving along a straight line. Say OP. It moves from O to P in 18 seconds and returns from P to Q in 6 seconds. What are the average velocity and average speed of the car in going? First is from O to P. And B is from O to P and back to Q. So first part will solve here from O to P, and that we have to go for it. So accordingly we'll go for it. Average velocity equals to displacement upon, so for the same it will be average velocity upon time interval equals to average velocity is denoted by V bar equals to plus 360 upon 18 second, which is equals to plus 20 meter second inverse. Now we talk for average speed. Equals to path length upon time interval. So path length is 360 meter upon 18 second. So it will be 20 meter second inwards. So thus, in the case that the average speed is equals to the magnitude and the average average velocity. So we'll talk about for the case of B, and where average velocity equals to displacement upon time interval, which is equals to plus 240 meter upon 18 plus 6 second equals to 10 meter second inverse. Now average speed equals to path length whole upon time interval path length is OP plus PQ, and this is delta T. So it will be 360 plus 120 meter upon 24 second. It will be cancel it out and will give the answer 20 meter second inverse that we have. So thus, in this case, that the average speed is not equals to the magnitude of the average velocity, and this happens because of the motions here involves change in direction, so that the path length is greater than the magnitude of displacement. This shows that speed is in general greater than the magnitude of the velocity. On a way, if the car, in example, that what we had discussed in this question here, that moves from O to P and comes back to O and the same time interval, and average speed is 20 meter per second, but the average velocity is 0. Now we'll talk about for the another one, that what we'll have to discuss, and that is your instantaneous velocity and speed. Instantaneous velocity and speed. On the same way, the average velocity tells us how fast an object has been moving over a given time interval, but does not tell us how fast it moves at different instants of time during that interval. For this, we define instantaneous velocity, or simply velocity v at an instant t. The velocity at an instant is defined as the limit of the average velocity as the time interval delta t that becomes infinitesimally and small, and is in other words, we can say that it will be denoted in the form equals to limit delta t tends to 0, which is delta x upon delta t, and on the same way, that v equals to dx upon dt. That what we'll have here. So where the symbol limit delta t equals to 0, that stands for the operation of taking limit as delta t to 0, delta t to 0 of the capacity of the quantity of its right. In the language of calculus, the quantity of the right hand side of this is the differential coefficient of x with respect to t and is denoted by dx upon dt. That is, it is the rate of the change of position with respect to time at that instant. We can use this one for obtaining the value of velocity at an instant, either graphically or numerically. Suppose that we want to obtain a graphically the value of velocity at a time t equals to 4 seconds. Point P for a motion of a car that represented, and that has been the figure has been redrawn to choosing the different skills of to facilitate where to determining those from the position time graph. Velocity at t equals to 4 second to a slope and a tangent is to the graph at that instant as well. So we'll be drawing that. Here in that tangent it will be 0, 2, 4, 6, 8, 10, 12, 14 and many more to go. This is x, and here it will be 2, 2.5, 3, 3.5, 4, 4.5, 5 and 5.5 and 6. So this is in of TFS. So the slope will go here from 1, it will go as 2.5, then it will be moving ahead. That will go. This is the P1 point and this is P2. So it will be on a tangent way. This will make a slope like a structure, and that's what we'll have here. For those determining in it, and on the same way we'll be going to discuss that here in the detail, of course, that for calculations here on the same way, let us take delta t equals to 2 second, then the central of t equals to 4 second. Then by definitions of the average velocity, the slope of the line p1 and p2, that gives the value of average velocity over the interval over the interval 3 second to 5 second, and now we decrease the value of delta t from 2 seconds to 1 second. Then line P1 and P2 becomes Q1 and Q2, and its slope gives the value of the average velocity over the interval 3.5 second to 4.5 second, as you can see here. On the same way, in the limit that delta t equals to 0, the line P1 and P2 becomes a tangent of the position's time curve at the point P, and the velocity at t equals to 4 second is given by the slope of the tangent at that point. It is difficult to show this process graphically, but if we use numerical method to obtain the value of the velocity, that to be obtain the value of velocity, the meaning of the limiting process becomes clear. So with the same here, and for limiting process become that clear, and for that graph that to be shown in figure that further which we had discussed about it, where x equals to 0.08 t cube. So that gives the value of delta x by delta t that calculated for delta t equals to 2 second to 1 second, 0.5 and 0.1 second, and 0.01 second as well. That's entered at t equals to 4 second, where the second and the third column give the value of t1, which is t delta t by 2, and t2 equals to t plus delta t by 2 here. On the same way, and that the fourth and the fifth column that give the corresponding value of x, that is x t1 equals to 0.08 here, and the sixth column that lists differences, wherein the velocity which we have here in the column, we see that we decrease the value of delta t from 2 to 0.01 second, 0.10 second, and that the value of the average velocity approaches to the limiting value 3.84 meter per second inverse, which is the value of the velocity at t equals to 4 second, and that is the value of dx by dt at t equals to 4 second. In this manner, we can calculate the velocity at an instant for the motion of the car as shown. For this case, the variation of the velocity with time is found to be shown here. Now we discuss further which is the velocity time graph that is corresponding to the motion, and that is what we'll have to discuss here in the detail about it. And let's go for the same. So here we go. First we'll discuss the table, first we'll discuss about the table, and then we'll discuss about the graph as well. So the table, we have the limiting value of delta x by delta t at t equals to 4 second. So limiting value of delta x by delta t at t equals to 4 second, which is here delta t, t1 in second, t2 in second, x t1, x t2, delta x by delta t, which is in meter second inverse. It is in meter, meter, and this is what in second. So we'll find out. Here we go. So when delta t is 2, so we'll go for it. This is 3, t1 is 3, t2 is 5, x t1 is 2.16, x t2 is 10, and x t3 is 7.84, where delta x by delta t is 3.92. When delta t is your 1, it will be 3.5, 4.5, 3.43, 7.29, 3.56, 3.86, and 3.86. Now when it is 0.5, it will be 3.75, 4.25, 4.21875, 6.14125, 1.9225, and 3.845. Another is 0.1, 3.95, 4.05, 4.93039, 6.31441, 0.38402, 3.8402. Now 0.01, 3.995, 4.005, 5.100824, 5.139224. Then we have 0.0384, 3.8400, This is limiting the value of delta x by delta t where t equals to 4 seconds. Here we go. For the same. So now we talk about for the graph here. So for that it will be the graph will be have in here is as follows. So for the same it will be 0, 2, 4, 8, 6, 8, 10, 12, 14, 16. So here we go for the same, and that will be having here in the consistent 16, and then we have your 18 as well, and then your 20 as well. That has been your t of seconds here. This is OB meter per second, which has been here. It will be 5, 10, 15, 20, 25, and this is 30 here. Now for that velocity time graph that is corresponding to the matrix that is being shown. So for here it will be from here to it will be drop of 10 and 25. This is an instantaneous. Then we'll be having the straight forward line that would be exceeded towards, then it will be drop for 20 here. So further it will be, as you can see here, from 0 it will start, and from then it will be the uniform, then it will be the inverse, and then with the retarded. So here that the graphical in the same way we'll talk about for this. So here for the graphical method for the determining of the instantaneous velocity is always not a convenient method. For this we must carefully plot the position time graph, and to calculate the value of the average velocity as delta t to become a smaller and smaller. It is easiest to calculate the value of velocity at a different instant as well. And if we of a position at a different instant, and expressions for the position as a functions of the time, and then we calculate delta x by delta t from the data to the decreasing value of delta t and find the limits value as we have done the differential calculation of the given expression, that is to be calculate dx by dt at a different instant as done to the way following that what we had done. So now we're gonna end up with thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. We'll discuss the rest of the question with and the rest of the topic in the next coming class. That has been the helpful for us as well. So we'll going to end up, but before ending it up, we had done your chemistry part 1 for class 11, and even though we had done your physics chemistry part 2, we are dealing here for that is being the organic chemistry. We had done your the reasoning, that is your verbal reasoning and non-verbal reasoning. We are dealing with the DBMS, we are dealing with the CBNST, we are dealing with English vocabulary. We had started with the quantitative aptitude, where we had started with arithmetical ability, and that we had done 16 topics, and now we will be covering up the 17 topics surely, and we'll end, after ending it up we'll start discussing about the bank's examinations paper, question paper. In terms of physics part 1, that what we had does is your unit 1 physical 1, which we had done, and unit 2 units and measurement, which we had done. In unit 1, which in the physical world we had done what is physics, scope and excitement of physics, physics technology and society, fundamental forces in nature and nature of the physical laws. In unit 2, which we have to cover up the units and measurement, that is introduction, the international system of unit, measurement of length, measurement of mass, measurement of time, accuracy, precision and instrument, and errors in measurement, significant figures, dimension of physical quantity, dimensional formula and the dimensional equation, dimensional analysis and the application as well. Unit third, which we have to cover up, is your motion in a straight line. In that we had completed your introduction, position, path length and displacement, average velocity and average speed, instantaneous velocity and speed, acceleration, kinematics, equation for the uniformly accelerated motions, relative velocity, motion in a plane, that is unit 4. Unit 5, which we have to cover up here, is your laws of motion. Unit 6 is your work, energy and power. Unit 7 is the system of particles and rotational motion. Unit 8 is your gravitation. So here we're going to end up with thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Please like, share and subscribe, so more and more videos will be uploading you according to your requirement here. Thank you.